Hello, everyone. Welcome to today's lesson. As we delve into the realms of intelligent manufacturing and industrial automation, the trajectory path drawing workstation serves as a quintessential application case. It enables us to precisely simulate the motion trajectories of robots, optimize workflow processes, and enhance production efficiency. Today, we will use RoboGuide to build a trajectory path drawing workstation step by step. I hope that through today's lesson, you will master this skill and be able to apply it flexibly in your future work. Next, we will begin our learning with a hands-on task. By the end of this lesson, I hope that you will become proficient in using RoboGuide to create a new workspace and correctly select the basic functions, model types, and software versions of the robot. You should also be able to successfully add the training platform and parts to the workspace, accurately adjust their positions to ensure that the workpieces do not exceed the robot's working range, and avoid any interference or singularity errors. Let's begin Task 1, Building a Trajectory Path Drawing Workstation. First, open RoboGuide. Next, click on New Cell to create a new workspace. In the subsequent creation wizard, there are a total of 9 steps. Step 1, Process Selection. This is where we select the basic program for the robot. Choose Handling Pro and click Next. Step 2, Work Cell Name. This is the name of the project. We can change the project name here if needed. If no changes are required, simply click Next. Step 3, Robot Creation Method. This step involves selecting the method for creating the robot. Choose the default option and click Next. Step 4, Robot Software Version. Here, we select the software version for the robot. Typically, choose the latest version and click Next. Step 5, Robot Application Tool. This is where we select the default tool for the robot. Choose Set EOET Later and click Next. Step 6, Group 1 Robot Model. This step involves selecting the robot model. First, click on Order Number to sort the robot order numbers in ascending order. Locate the order number H754 and click Next. Step 7, Additional Motion Group. This step is for adding additional motion components to the robot. Since we do not need to add any extra motion components, we can directly click Next. Step 8, Robot Options. This step involves selecting optional software for the robot, such as language packs or software packages. For this project, no additional components are required, so we can directly click Next. Step 9, Overview. If there are no issues with the previous creation steps, we can directly click Finish to start creating the project. After the project is created, there is currently only one robot. We need to add some additional components. First, add the training platform. Right-click on the fixture property, select Add Fixture, and then choose Single CAD File. Navigate to our model library to find the training platform and add it to the project. Done. After adding the training platform, we need to move it to a suitable position. We can rotate the view or zoom in and out. At this point, we can see the location of the training platform. There are 2 ways to adjust the position of the training platform. One way is to click on the training platform and drag its coordinate axis to directly move the object. The other way is to modify its position in the Location section under the General tab of the training platform's properties. Once the position is adjusted, click Apply to confirm the changes. The training platform is now properly placed. Next, we need to adjust the position of the robot. First, click on the robot in the left-hand menu and drag its coordinate axis to move it to the desired location. After positioning the robot, we will add the workpiece. To do this, right-click on the Parts property and select Add Part, then choose Single CAD File. Locate and add the workpiece drawing model. When loading the workpiece, it is important to select high quality to ensure that edges can be detected in subsequent steps. Once the workpiece is added, the next step is to place the drawing module on top of the training platform. To do this, right-click on the training platform in the left-hand menu and select Properties. In the third tab, Parts, check the box next to the drawing module that we just added and click Apply. Next, click on Edit Part Offset to adjust the position of the drawing module. At this point, we need to adjust the position of the drawing module to place it in a suitable location. What is the criterion for a suitable position? The placement of the drawing module should not exceed the robot's workspace, and it should not cause any interference or singularity errors for the robot. How can we evaluate this? We can click the Show Hide Work Envelope button in the menu bar. If the workpiece model does not exceed the robot's workspace, it meets the first criterion. Additionally, avoid placing the model too directly in front of the robot, as this may lead to singularity errors. Then, click Apply to confirm the changes. With this, we have successfully created the Trajectory Path Drawing Workstation. Finally, I encourage you to try operating RoboGuide on your own and build a Trajectory Path Drawing Workstation according to the steps we have covered in this lesson. Please feel free to share your experiences and any challenges you encounter along the way. In today's lesson, we have learned how to use RoboGuide to build a Trajectory Path Drawing Workstation. We have progressively completed the construction of the workstation, from creating a new workspace to selecting the robot's basic program, model type, and software version, and then adding the training platform and workpieces while adjusting their positions. I hope that you have become proficient in these skills and will be able to apply them flexibly in your future work. At the same time, I also hope that you will maintain your passion and curiosity for intelligent manufacturing and industrial automation, and continue to explore and learn new knowledge and skills.